Can we have Dr. Miklos Marosfoi for cyclical aspiration technique improves clot ingestion and reduces fragmentation?
Thank you very much for the opportunity to be here and present our work. Before I go in details about cyclic aspiration, just a little bit about the background, how we get there. I have no financial interest to disclose here. I think this is a very important paper published recently by Dr. Zaidat and his colleagues, showing the data which I believe we all believe this is the case, to reach first pass efficacy, TICI recognition as quick as we can, because this is correlating to the patient clinical outcome. If you look at the mortality, there is a huge difference between TICI-2B and TICI-3. And if you look at the good clinical outcome, there is like 20% better functional outcome. So we really want to have more and more TICI-3 recognition. We have the ASTER trial, which showed no significant differences between the contact aspiration and stent reverse groups. But if you look at the TICI-3 recognition, it's around 30%. So we need to improve this in the future. Recently published the TAP technique long-term experience. If you look at the TICI-2B3, you are pretty close to 100%, which is amazing. But if you look at the TICI-3, it's just below 50%. So what can we do to get better on this? In one of our previous study, we understood that in order to reduce distal embolization, because this is how you get TICI-2B, you have some distal emboli, you have some sort of complication, you need to completely ingest the clot. Here's a video showing how this should work in a clinical case. You get close to the clot, and then the clot is aspirating. So we know that the full clot ingestion can reduce distal emboli. Cyclical aspiration is not totally new. There is a paper published by Simon and colleagues. They show that cyclical aspiration is better than static aspiration in terms of clot removal. But we really wanted to understand what's going on distal to the clot, how much distal emboli we are generating if we do static or cyclic aspiration. So we use a patient-specific replica. We use a hard clot. It's important to mention if you have a soft clot, you can get the clot out easily. The problem is always with hard clots. So how can you get it out? So these clots were representative to the clots removed from a patient. We use a flow loop. We use a large bore catheter, O70, which we get close to the clot proximal, not to the face, 2-3 millimeter proximal to the clot. We use either 29-inch mercury static aspiration or cyclical aspiration. We never let the aspiration go down to 0. So it's 29, 18, and basically we got this for 2 seconds for each number. We had 8 experiments per group, and the question we wanted to answer is, what's the rate of complete clot ingestion? Because this is what we want to have. If it's not happening the way we want, what's the length of the clot inside the catheter? And the third question is, how much distal emboli we are generating by this procedure? So quickly, the technique we use, we never cross the clot. If we get the catheter to the face of the clot, we intentionally pulled back a little bit to get this gap between the catheter and the clot, and then start aspiration and re-advancing the catheter to the clot and trying to aspirate. If there was a full ingestion, we just removed the catheter. If not, slowly we pulled back. We call this pace technique. In terms of the results, on the left, you see the complete ingestion in 2 groups. So with cyclic aspiration, almost in 50% of the cases, we had complete clot ingestion, but we have never seen in the static aspiration. Again, these are hard clots. This is the clot which is hard to remove in a clinical scenario too. If we get the clot inside the catheter, we measure the length of the clot inside. And if you look at the figure on the right, you see that with a cyclic aspiration, we had twice as long clot inside the catheter. Both were significantly different between the groups. And I don't know why I cannot advance my slide. I need some help. Oops, and now I need to go back. Yeah. Another very important thing is how much distal emboli we are generating with these two techniques. So if you look at the clot fragments larger than 200 microns, which I believe this is the size of the clot beyond 200, which goes towards the TICI-2B recognition. And if you look at the other figure, less than 200 microns, this is the size of the clot where you see mostly a TICI-2C recognition. A lot of small emboli, distal slow outflow. On the left, I show all 8 experiments, and you can see that the number of fragments with static aspiration was between 1 and 4. We had 2 experiments where we had only 1 large distal emboli with cyclic aspiration. In terms of the small clot fragments, there was no difference between cyclic and static aspiration. So in summary, I would say we learned that if you want to have a good recognition with aspiration, you really need to get a complete clot ingestion to reduce distal emboli. We have some possible explanation which needs to be further evaluated. We think that oscillating pattern can initially softening the clot by dynamic compression. And you may direct the clot. This is what we were able to visualize, because in in vitro model, the huge advantage is you actually see what you're doing. So what we have seen here is with cyclic aspiration, you have seen the clot moving proximal to the catheter, and they meet at some points, so it was a pretty good alignment with the clot and the catheter. So we think this helped to get a full clot ingestion. And if once you get the clot cord into the catheter, will stay there. If it's a hard clot, it's not changing. You basically, the static aspiration cannot overcome the static friction. Thank you for your attention.